Hi friends, welcome to the Unit 3 Day 1 notes. Now we're on page number 3, finding the value of x. And that's all that it says. It doesn't say use the formula that we used on the previous page, although we need to. Because first we need to figure out how many sides this shape is. This shape has 4 sides, it's a quadrilateral, and I know that I'm looking at the interior angle measurements, so I'm going to use that formula that we just had, that n minus 180, n minus 2 times 180 equals, and we actually have to know what that end result is going to be. So I can find that for this one. This is a 4-sided shape, so this is going to be 4 minus 2. So 4 minus 2 times 180. I'm actually going to use the left equals to showcase this. 4 minus 2 is 2. 2 times 180. So this is a 360-degree interior angle, also exterior, but we're just looking at interior right now. This is a 360-degree shape. That tells me that if I add up all of these interior angle measurements, if I add up all of these, I'm going to get or obtain 360 degrees. So if I add up 108 plus 121 plus 59 plus x, that result should be 360. Notice that I did not put degree measurements or the degree measurement symbol next to each of these. It is assumed that we're going to keep that value. Also note it wants to find the value of x, and x already has a degree symbol there. So it's just a nice way to help us save some work. At this point, you know how to do this problem. We add up 108, 121, and 59. We would obtain 288. So if I have x plus 288 equals 360, to get x by itself, I subtract 288 from both sides. Again, using that subtraction property of equality that we've talked about earlier, I get x equals 72. And that's it. That's all we need to do. Again, find that value of x. For this shape, it is a 1, 2, 3, 4, 5, 6. Wait, did I count this one? That's a common mistake students make. So one thing that you can do is to make a tick mark next to where you started, so you know. Now notice that tick mark also is the number 1, so that tells me where I had. So this is a 1, 2, 3, 4, 5. This is a 6-sided shape. So that helps when you're trying to figure out the number of the degree measurements that this shape has. So 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180 is 720 degrees. So I know that the interior angles of this shape have 720 degrees. So now I need to add them all up. So I add 121 plus 96 plus 101 plus 162 plus what? Square? Don't forget, that's a right angle symbol. Right angles have 90 degrees. We do need to count that. Otherwise, we won't have all the right measurements, and we'll have a wrong value for x. Plus x equals 720. If you add up all of these values here, you obtain 570 plus x equals 720. Subtract 570 from both sides, and you get x equals 150. Again, we don't need to put the degree measurement on this because we already have the degree measurement here. Then we've talked about the interior angle measurements and how we can solve these. What I'm going to do next is talk about the exterior angle of a polygon. So an exterior angle of a polygon is an angle formed by the side of the polygon and extending the other side. And what does that mean? If you look over here, what I'm going to do is I'm going to extend out using this here, using a straight edge. Here we go. Look at this convenient straight edge. It's the first page of notes. So if I extend out this side right here like this, what I end up with is here this angle measurement. And then I want to keep doing that along the same path as I go through, so I can extend out. Notice I'm using a straight edge. I am really particular on this in constructions. Whenever you make a construction, always use a straight edge if possible. So whenever you're constructing something, always use a straight edge. That's how we're able to do marvelous things too, and then so forth. So these exterior angles are formed by this. Remember, we talked about the sums of the exterior angles on the previous page. So the Polygon exterior angle sum theorem, the sum of the exterior angle measures one angle at each vertex of a convex polygon is 360 degrees. Note that this angle measurement here, I've set this up in a way that I have to continue following the same pattern where I'm extending this out like this, extending this one out. So I can't go back and kind of double back on this and change my path. I have to keep the same path as I go through. Otherwise, I will end up with the wrong value. So the filled out notes are actually incorrect for this. We haven't updated it. It has the wrong value here for this one. So this is 3, 4, and 5 as you go through. So again, a lot of students get confused on which one it is. This side is 180 degrees, so it wouldn't be that one, it would be this one here. And it does add up to be 360 degrees. So here, same idea, find the value of x. These are all exterior angles, so then we would just set it up by adding 65 plus 106 plus 78 plus x equals 360 degrees. Again, I'm not putting the degree symbol on these because it's already provided on that x. If you add all those together, you get 249 plus x equals 360 minus 249 on both sides. You get x equals 111. And then for this example here, very similar, except now we have a couple of just oddly different things. So if I do 90 plus 60 plus 4x plus x plus 2x, I am still going to sum up to be 360. But now when I combine these, 90 plus 60 is 150, and then 4x plus x plus 2x is 7x. So I'm going to have a few more steps to work on for this particular problem. Subtract 150 off both sides, and you get 7x equals 210. Divide by 7, and you get x equals 30. Now, in the next video, we'll talk about what it means to be an equilateral, equiangular, and then also a regular polygon. I'll see you in a bit.